Shall we start with the first presentation?
Who's the first one? I see paper ID 855 is the first one. Anyone here to present paper ID 855?
Paper ID 914.
So we'll start soon.
By soon you mean?
Hello, good morning, sir. Yeah, paper ID 914.
Yes, you can start with your presentation.
Okay.
Good morning, everyone. I hope you're all doing well. Welcome to the International Conference on Pervasive Computational Technologies 2025. My name is Shivan and I welcome all of you to the theme of machine learning algorithms. I am honored to serve as the session organizer for this session. Before we begin, I would like to acknowledge our esteemed session chairs who will be guiding us through today's session. We are honored to have Mr. Naveen Ananda Kumar and Dr. Shubham Mahajan and uh, and ma'am and Dr. Archana ma'am with us. Their expertise and insights will add great value to our discussions. Thank you for being a part of this session. I'd like to warmly welcome all our session chairs, presenters, and attendees for joining us today. Each presenter will have 10 minutes to present, followed by a brief Q&A session for 5 minutes. A quick reminder to keep all of your microphones muted when not speaking to minimize background noise. If you experience any technical issues, please use the chat function and support team will assist you. This session is being recorded, so we appreciate your cooperation. And our first paper ID is paper ID 855 and their paper title is Teaching Machine Learning in K-12 Education. The authors may present themselves. Anyone from 855 is present here? We'll skip the first one. Second paper ID is 914 and their paper title is Preliminary Poultry Disease Identification. The authors may present themselves.
Hi, good morning, everyone. Actually, I have my share option is not okay. Thank you. Is this visible? Can anyone?
Yes, it's visible.
Okay. Hi, good morning, everyone. My name is Purvi Chauhan, and I am presenting my conference paper, which has been titled as Preliminary Poultry Disease Identification: A Comparative Analysis of Classifier Utilizing PCA for Improved Agriculture Health Surveillance. Okay, so these are the list of table contents, whatever I am going to present. It includes introduction, problem statement, objective, methodology, and analysis, results, and conclusion. So, first of all, I would like to give a brief intro about my area. So, I am working on the disease identification in poultry farming. So, basically, poultry farming is a practice of raising all the domesticated birds such as chicken, ducks, turkeys, geese for meats and egg production. So there are basically three kinds of poultry farming which has been done in India. First is broiler farming, second is layer farming, and third is free range farming. So broiler farming, in which we it is a practice of raising the chickens for specifically for meat production, and layer farming is the raising of chicken for commercial egg production, and free range farming, basically in this type of farming, all the animals can have access to the outdoor for the for at least a part of the day. And these are the some of the key aspects which have been mentioned. So basically, while designing a poultry farm, so housing and farming layout plays an essential role, and also
Ma'am,
the
please move your PPT.
okay, okay, just give me a second. Huh? So next is nutrition, feeding, disease management, and economic importance.
Ma'am, it is
These
on
are
the
the
first page only.
okay, okay. So next is, as we have seen the global production of poultry products. So this is a graph representing the chicken meat production worldwide. So as we have seen that it has been increasing day by day. So it is very mandatory. Uh,
Urvi, your
Some issue
slides are
with your,
not
yeah.
moving.
so are these not moving?
Now it has come to
Kindly
introduction
move on
and
to the
brief review.
sixth slide. No, it's moving. No, it's moving.
Okay,
Kindly
okay.
proceed.
So I have to start from the previous, or I will just
No, no,
move
you
to next.
continue.
Okay,
Next.
okay, okay. So this slide shows the globally egg production. This is the last 12 years, sorry, 18 years data. So as we seen the demand has been increasing day by day. So it is very necessary. Uh, uh, yeah. Next, so why the need for chicken health monitoring? So basically, it leads to the food security, economic saving, and the public health, and also the
If we come to your proposed methodologies,
okay, okay.
what you have proposed.
So directly, sir. Okay, yeah.
Objectives and then proposed methodology.
Okay, sir. Okay, sir. So basically, what I have proposed is like to use the traditional machine learning approaches to identify the disease at an early stage. So I have used four classifiers: random forest, decision tree, support vector machine, and KNN, and integrated with PCA, principal component analysis, for early disease diagnosis. So I have take total like 191 color photos of coccidiosis diseases and 191 photos of healthy fecal matter. So first, what I have done in this, so I have collect all the data set and just process the image, and then just split my data set into training, validation, testing, and use PCA for dimension reduction. So I have take 10 statistical features, and then just I have used the important, like only the important features as area and parameter. I am focusing on that. And after that, all these models have been trained and just take the evaluation. So finally, like the classification report has been shown here. So my random forest model shows 95% of accuracy. The most accurate model is, and yeah, all the other parameters matrices.
So in this, you have used the predefined algorithms like decision tree SVM for training and testing of your data,
Yeah, sir.
or
I
you
have just
have
modified a little bit in these.
modification in context of what you have modified in them.
Sir, already these classifier are inbuilt. Yeah, all these decision trees and KNN random forest.
But
So
what you have modified, you just said that you have modified a bit in them.
hello. Yeah.
Yes, yes, tell me what you have modified, what
No,
you
no,
have
no, sir. Sorry,
updated.
sir. Sorry, sir. Yeah, I have just said wrong. I have directly used all these classifier. Just
Then what
I
is the
wa-
novelty of that of the work
Sir,
when you
like
are
I can directly use the classifier like for testing the performance. Even though right now all the hybrid models and even deep learning model is also we are working on that. But just for the sake of the like for sake of the novelty, or I will say that like for like what I want to propose is like I want to utilize least resources and also go for the traditional approaches of the machine learning. So first, because the only reason for including PCA is like it shows a good result rather than using directly the all the models, like directly implying the model.
Can you state the difference between SBM and decision tree?
These both models are basically both are different classifier to classify the object. So support vector machine in this whenever we are using the classifier, so it has been divided like we are using as a hard mark, like in this support vector machine two kind of classifier like hard margin classifier or soft margin classifier are used to identify, and decision trees are all the decisions has been taken in the tree form, like yeah,
And
branch
what
form.
is KNN?
The k nearest neighborhood. So what we are trying to find out, so it has like according to the data points or the nearest neighbor, it can predict the output.
From where you have taken the dataset?
So I have taken it from GitHub, yeah, open repository.
What is image acquisition?
So actually, image acquisition is taking the all the data set from the sensors, yeah, collecting the image data from different sensor or camera or whatever the source.
Taking different dataset?
So
The
the
first
original
time
data
you have
set,
said.
like from different sources, the data set.
Image acquisition is collection of
Yeah,
different datasets from different sources.
yeah.
Is it your BTech, MTech or PhD work?
So I have started my PhD. Yeah, this is my starting of PhD.
Okay. And can you show the references?
Yeah.
Okay. Over to next session, Chair.
Any other question from anyone else?
Hi, Purvi. This is Naveen here.
Yeah,
I
hi sir.
see go to methodology once. In image preprocessing, you have mentioned a normalization. So what did you do in that normalization exactly?
Sir, actually all the data set which I have taken from the GitHub, like online resources. So it was like it consists of some blurring of images and like yeah, it all the some of the images consist of noise. So I was just denoising and yeah,
Okay, what
deblurring.
approach for denoising?
Sorry, Gosh,
What approach you use for denoising? What is the method you followed?
sir, I have used Gaussian filter to remove noise.
Okay, fine. And what is the percentage proportion of test and train data?
Yeah, sir, 70 and 30%.
Okay, that's it from my end.
We will proceed to the next presenter, 951.
Okay, thank you so much.
Anyone from paper ID 951 is present or not?
Yes, sir. We are unable to share the screen, sir.
Just a second.
Who is going to present?
Ritika.
Okay.
You can share your screen now.
Yes.
Ritika, please limit your presentation to 10 minutes.
Okay. Sir, is it visible? Ma'am, can you see
Yes,
it?
it is visible.
Yeah. Okay. So, good morning to all the panel members. Here, our team are going to present a research paper on network threat monitoring system using machine learning. So, in the recent times, we have seen that the cyber attacks have been increased by 72%, and all the the cyber threats have increased by 72%, and most of the traditional methods actually fail. And due to improve that, we are actually introducing the network threat monitoring system using machine learning. The model actually, the key highlights of a model is ensemble learning using stacking classifier and voting classifier. The data set that we used in our model is an improved version of KDD Cup 1999. So why we actually choose this, because most of the traditional intrusion detection methods face challenges like their inability to detect threats, and also they have high false positive, and they have failure to detect sophisticated cyber attacks. And the existing individual machine learning models often generate false positive. In order to reduce that false positive, we have gone through a method using ensemble learning. The main objective of our project was to improve detection accuracy using ensemble learning, to minimize false positive and false negatives, and to enable real-time monitoring for proactive security, and also to develop a scalable and adaptive system for dynamic cyber threats. Uh, Next is the methodology and analysis. First is we've used the data set NSL-KDD, which is an improved version of the 1999 KDD cup. It has almost 41 features, which has almost 80 percentage of attack records and 20 percentage of normal records, which provides an imbalance in the class features. And to overcome all that, we've used data processing techniques and also class imbalance fixing techniques. For the data pre-processing techniques, we've removed inconsistencies, and we've also used feature scaling methods like min-max scaling. And for the class imbalance, which I already told, which is like 80 percentage of attack records and 20 percentage of normal records, which will affect the training rate. We've used class imbalance fixing method called SMOD, which is synthetic minority oversampling, so that we'll have a balanced data set. Next is we've also used a feature engineering, which uses autoencoders. This is used to reduce the noise and improve the classification accuracies. And we've used model base models like decision tree, random forest, and gradient boosting. These are like separate models, and we've used that in our ensemble learning, which is like stacking classifier and voting classifier. In stacking classifier, we've combined a random forest, gradient boosting, and logical regression. For the voting classifier, we've used decision tree, gradient boosting, and random forest. Um, Next is the model performances. Um, as you can see, stacking classifier has achieved about 95 percentage of accuracy, whereas sorting classifier has achieved about 98 percentage of accuracy. Both is like has significantly reduced the false alarm, which makes those classifiers ideal for real world implementations. And the data pre-processing method is also played a really important part, because which is reduce the imbalance in the class, and also reduce the noise in the to improve the data quality. Next is a conclusion. our model has proved to detect cyber threats with higher accuracy. This has also drastically minimized the false positives. So that basically false positive is that even there is a small change in the network traffic, it considers that as a threat, which reduces the reliability of the system. So we've drastically reduced those false positives, and thus providing a scalable solution for networks. And moving forward, we've also hoped to integrate those with the AI-powered security platforms, and in also deploying them in IoT and smart home devices as well. Thank you.
Can you distinguish between insider threat and social engineering threat?
Cyber threats are the threat that we have. There are a lot of, I mean, cyber threat is the threat that
No,
we
no. I am asking about insider threat and social engineering threat.
insider threats are actually performed by the people who are actually in the organization, mostly like an employee or like a person who is actually has an authority to overlook it, but they use it in a for their own benefits, like they misuse their the authority. And the next one that you asked, what was it? Social
Social
engineering.
engineering.
Social engineering threat is like it affect they basically affect the human psychology by fooling them, or doing something like that to gain the access to your computer network.
And what is the name of your dataset?
NSLKDT.
Is it open source or you have requested it from somebody?
No, it is available publicly both in Kaggle and then in IEEE.
Okay, thank you.
And Ritika, can you go to your analysis methodology analysis lab?
Yes, sir.
Okay, result and discussion. The next one. Yeah, if you see, like, you have used staking classifier and voting classifier, you have used various models, right? So what is the reason for choosing this one when you have multiple others and most advanced kind of learning models already available?
Can you come again, sir?
Yeah, like what is the intention of using like decision tree, gradient boosting, and random forest, considering we have many latest model available in the market right now?
The gradient and the random forest is already proved to work to a really good level, but it has to be developed only for the false positives. So we've combined these as a base model, and the output of these models has been taken as the input for the meta model for the stacking classifier. The meta model actually learns to make the final prediction.
Okay, and what is the configuration of the environment you have used for this analysis?
Configuration. I mean, like we've used the data set and we've created a model and
Hardware configuration, I mean.
uh, configuration. You mean like hardware configuration?
Yeah.
It is just a GPU and a RAM of 16 GB. That's it.
Okay, and how long did it take to complete end to end?
I've been working on this for almost like 2 months or something to research and then like do it.
Okay, fine.
Any other question from any participant?
One question, Ritika. This is an imbalance class. Any reason why you choose accuracy as your evaluation metric or any other metrics that can help more?
We've also made other evaluation metrics, but I've improved the accuracy, so I've mentioned the only the accuracy. We also used F1 score and other metrics as well in our prediction.
Thank you.
Thank you, Ritika, for your presentation. Now let's go to the next presenter, paper ID 1008.
Thank you.
Anyone from 1008?
Anyone from paper ID 1008 is present here or not? 1220?
Yes, sir, I'm there. Can you give me 1 second? Can you see my screens?
Yes, it is visible. Please start from first slide. Yes.
All right. Thank you so much for the opportunity today.
Yeah, now
I'm
continue.
present. Yeah, can you hear me?
Yes, yes. Can you guys?
Yeah,
Yes.
can you? Okay.
Thank you.
This paper is about a comprehensive analysis of machine learning approaches for stock price prediction. Quickly going over the introduction. So we are trying to forecast the machine learning. We're trying to forecast the machine learning models that the two models that we have used here is, traditionally we have ARIMA, random forest, and different other models that are available. But the problem was the stock prediction has a lot of accuracy issues. So we were trying to compare this against the long short term memory and the XE-boost, extreme gradient boosting for stock prediction. And the data source that we used here is Yahoo Finance, and we are trying to do this analysis for AMD. So like I said, the problem statement was the stock market prediction is highly complex and it's volatile, and we the data every day it's a dips, right? So we traditional methods are struggling to handle large data and dynamic data sets. So we wanted to compare this against the ML based approach. We wanted to use AI and machine learning models to see if we can get accuracy with the models that are available in the market. And like I said, we were using LSTM and XE-boost models for stock prediction. The objective here is we were analyzing the stock market trends. We were using performance metrics such as root mean square error, MAE, and R square. And we're trying to provide insights into model selection for different financial forecasting applications. So the methodology that we used is like I mentioned previously, the data set is we are doing stock prediction for AMD, and the data that we pulled out from is from Yahoo Finance. We've been pre-processing this data where we used certain metrics to process, where you use the close price on a given day, and we normalized it by min-max scalar. Also, we use 60 days rolling window. This this is the feature where, the 60-day feature where we are only using past 60 days of data. And for the training, we have used 90% of training and 5% of testing. So the models that we are trying to compare here is LSTM and XGBoost. The reason that we picked LSTM is it does a sequential model capturing for long-term dependencies, whereas XGBoost also is as power as LSTM. It has gradient boosting algorithm optimized for structured data, and whereas LSTM is more for the sequential models. Evaluation metrics, like I mentioned, we were using couple of metrics here: root mean square error, mean absolute error, and R square scores. From our analysis, the results came out to be that LSTM model was extremely outstanding here. We had better performance with LSTM model when compared to the XGBoost. The reason that I'm saying that LSTM, you can see that the numbers are lower here on the RSTM, which means that this has a better performance. And whereas you see that R square score is greater, so you will have to see that these scores are less than the lower the score, the better the accuracy. That's how we predict them. So we've noticed that LSTM has a better accuracy level when compared to the XGBoost. Also, we try to have a, despite high in many cases when we are trying to deal with stock market prediction, the volume of data is high, and the computational cost is something that we have to keep in keep in mind when we are using LSTM models, because that's one of the flaws with LSTM models, where you always have to, it has a high computational cost. So that was the drawback. In the conclusions, what we came out to see here is LSTM captures more sequential dependencies, making it suitable for long-term prediction, whereas XGBoost excels in speed and efficiency, making it ideal for real-time applications. So further research can explore a hybrid model which combines both the techniques. The additional improvements can include more feature engineering to make sure we can add more metrics and expand on that. That's all from me. And we have references in the last slide. Any questions, sir?
Is there any question from anyone, presenter, session chairs?
Yeah, like what's the reason for using 95% of training data? Did it cause overfitting issue?
That's correct, sir.
That's correct, sir. Yes.
Yeah. So the thing is, we tried to use first we tried with 70-30, sir, but the thing is, we did try to overfit. So then again, we expanded that scope to 80-20, and then 95-5 did suit well, sir, because of the data sets. As you guys know, sir, we are dealing with I mean, this long-term trend analysis with especially stock market data with the real-time price metrics for every minute that we had to deal with, and this data sets that we chose, I mean, even for 60-day range, sir, we were initially exploring the different close prices per every minute, every hour. But yeah, due to the overfitting issues, yes.
Okay. And what is the interval of the data? It was like a minute level or a second or hourly?
So the thing is, sir, we initially tried minute level, but the minute level, the problem with the minute level that we face, sir, is basically, I mean, the price fluctuation is very high, and it's the thing is, we were not able to make enough predictions with that data, especially like, I mean, the way that AMD price has like high fluctuations, as you know, with all the I mean, the chip stocks in recent times have high fluctuations. And this is like one of the good examples that we chose for this particular project to compare LSTM versus XGBoost because of the predictions against this volatile data. But yeah, we went with 1 hour data, sir.
Okay.
Yeah.
And what was the source of your data?
Yahoo Finance.
Yahoo Finance.
And it's an open source, sir. We picked everything from Yahoo Finance, and we went with like 1 year.
Yeah, past 60
And
days.
the current data is of which year? 2024 or 2023
Yes,
or
yeah,
any
yes.
other year?
No, 2024, sir. We started this data. I mean, we examined all the 2024, and we also started examining the data from the past 6 months. And but for the current metrics that you saw, sir, it's only for 60 days. But we examined the
And,
6 months data too, sir.
and can you number the stocks which were present in that particular data set? Total
So
number of
we
stocks?
we did the analysis for AMD, sir, in this particular paper, but we also compared AMD, Apple, and we also compared uh, kind of like some of the Russell Index stocks, sir, which has high volatility too. Like not the S&P 500, but the Russell Index, like apps and stuff. We just compared those stocks. Yeah.
Okay, okay, thank you.
Thank you, presenters. Now let's move to the next paper ID is 1224.
Paper ID 8559100811604 are absent.
As of now, they are not there.
Okay.
Uh,
Paper ID 1224.
We have paper ID 1020. You can start presenting. Doesn't come.
1020.
Your mic
uh,
is muted.
so this has been included at the last moment. So this is paper ID 1020.
Yeah, sir. Hello. Am I audible, sir?
Can you share the evaluation link of the same?
It's 1020 paper ID, sir. Am I audible?
Yes, you are.
Who's presenting?
Sir, it's paper 1020, sir. Am I audible, sir?
Yes, you are
Yeah.
audible, but your presentation is not visible.
Yeah,
So
sir.
kindly share.
Presentation is not visible.
Kindly share it again.
Hi, this is
Wait.
Naveen here, session chair. So, where can I update the score for this evaluation? 1020. I don't see it in the evaluation.
Yeah, we have to add this.
Okay, can I add it
It's
as
not
a
a. Yeah, you can add this. You can. Please share your presentation 1020 paper ID.
Yeah, ma'am. Just a minute. Is it visible, ma'am?
No.
I shared the
Yeah,
screen, ma'am.
it's visible now. You can start now.
Okay, shall I start, ma'am?
Now it is not visible. Earlier it was. I don't know what has happened. Yeah, now it is visible.
Okay. Good morning, everyone. I am Rajnikant Munda, and today I am presenting my research paper on comprehensive framework for grammar correction with GPT 3.5. So here are the contents, that is introduction, literature review, problem statement, research objective, methodology, experimental setup, procedure, result and discussion, conclusion and future scope, and last one is the references. So let's start with the introduction. So grammar error correction, that is in short GEC, plays a crucial role in improving written communication. And GPT 3.5 developed by OpenAI has demonstrated remarkable advancement in natural language processing. This study examines its efficiency in grammar correction compared to traditional tools like Grammarly and Microsoft Word and Google Doc. So And the next slide is literature review. So here are some literature review which I reviewed. And previously, research has explored various grammar correction model, but there is a gap in evaluating GPT 3.5, especially for this purpose. So our study fills this gap by comparing its performance with existing tools across different writing styles and error types. Now, moving to the next slide, that is problem statement. The key objective of these studies are to assess GPT 3.5 accuracy in correcting grammatical correction across different text generation, to compare its performance with existing, to identify areas where GPT 3.5 can further optimize. Now, moving to the next slide, that is the research objective. The primary objective of this study is to perform a thorough comparison between GPT 3.5 and traditional grammar correction tools such as Grammarly, MS Word, and Google Docs in order to determine their respective advantages and disadvantages in the range of linguistic contexts. Now let's the main part, that is the methodology. Okay. So we compiled a data set containing grammatically incorrect sentence from source like academic writing, news article, and social media. We used publicly available data sets such as CONL 2014, that is computational natural language learning. It is a data set we compiled a data set containing from that Kaggle. Now the and here are some sample, and you can say that you can see this kind of data set we have. And the next, this is a kind of a methodology flowchart. And the next slide is experimental setup. GPT 3.5 was tested alongside Grammarly, Microsoft Word, and Google Docs. We use the ChatGPT interface instead of OpenAI. The performance of these tools was then compared. Then here is the procedure, correction process. Then we fed up the data within GPT and using the prompt like correct this sentence and with and this one. And yeah, this one some screenshot which I shared with the procedure in part. Yeah, for the procedure, we use the to measure performance, we use accuracy, precision, recall, and F1 score. The accuracy is a the corrected errors versus total errors. The precision is that corrected positive correction versus all correction. Recall is that true positive versus total errors. And the F1 score is mean that harmonic means of precision and recall. And after that, one man is that evaluation matrix. This one some calculation we have taken this from the data set, and these are some screenshot which I shared as a result part. And now finally we comparing table from the grammar error correction, and after that we can set that the result and discussion. So our finding indicates that the GPT 3.5 outperform Microsoft Word and Google Docs in handling complex grammar correction. Grammarly perform comparatively but lack contextual understanding in some cases. And last one is the conclusion and future scope. So in this conclusion, GPT 3.5 is highly effective for grammar correction, but improvements are needed in reducing the overcorrection, enhancing contextual accuracy, expanding support for multilingual grammar correction, developing educational application, and etc. And the last one is that references. Here are some references, and that's all. Thank you. If you have any question, ma'am, please ask.
Rajni, can you share the presentation once, please?
Please, sir, please pardon.
Yeah, can you share the presentation and can you go to slide number 18 once?
Slide number 18.
18, not 18.
18 or 8, sir?
13 one.
13. Okay. Yeah, sir, 13.
So this error classification you have categorized based on corrections and missed error and over corrections, right?
Yeah,
So
sir.
like, was this done manually by you, or like did you use any other model
Sir,
to?
oh, right. This is, sir, manually we have done. The
Okay.
data set which is collected, sir, that is in not categorization, but we have done this one manualization.
Okay, fine. And there are most advanced ChatGPT model. What is the specific reason of using ChatGPT 3.5?
Sir, actually, in that, in which time I research I started, the 3.5 is I have a access for that. I have 2 months of access 3.5. That's why I have used that 3.5 only for that.
Okay. Yeah, that's it from my end.
Any other question? I don't think there is any other question. Thank you, Rajnikant, for your presentation.
Thank you so much, ma'am. Thank you.
One double 1008. Paper ID 1008.
Yes, ma'am. Yes, ma'am. Can I share?
Who is presenting from 1008?
Ma'am, Krupali here.
Krupali.
Yes, ma'am.
Okay, you can share.
Okay, ma'am. Thank you.
Ma'am, please share your presentation.
Yes, ma'am. Just a second.
Kripali, what is the problem?
Yes, sir. Actually, it's a network issue, so I don't have get that particular share option. So, sir, just a minute.
Yeah, please try me.
Yes,
We
sir.
have already given the share option.
Yes, ma'am. Is it visible, ma'am?
No. Ma'am, what is the issue you are facing?
Ma'am, just try to share a single tab only.
Yes, sir. Sir, can you give me a 5 minutes, sir? You can take a next presentation. Then I will continue, sir. If it's possible,
Nee,
then.
what is the issue you are facing? You are not.
Ma'am,
You
actually,
have just
from my system, I can't share that one. So I fixed that particular problem within a 5 minutes, ma'am.
Very good afternoon, ma'am. Here we are facing the issue regarding to share disable option. It's not enabled for our end.
Yes, yes, sir.
Paper ID, Mr. Om
Now
Prakash.
it's visible, sir?
1008.
Sorry?
Now it's
1008.
visible, sir?
1008.
Sir, is it
Who's
visible?
Yes, it's visible now. You may start.
Okay, sir. Good morning, sir. Good morning, all of you. My paper ID is a 1008, and my paper title is a Smart City Cyber Security, leveraging on a machine learning for advanced ransomware detection and prevention system. Now, let us start with some
Ma'am,
contents.
please
So,
limit your presentation to 10 minutes.
okay, ma'am. Now, in this particular presentation, we have included introduction and problem statement part. Also, we had discussed here our methodology and result related it and the future whatever the conclusion based on our research we had included in this presentation. Now, first of all, start with the introduction part. As we know that in smart cities, many of the particular challenges that compromises with cyber security, mainly related to infrastructure. So here, just we are
Your
working
slides
with
are
a
not
smart.
moving.
Sorry, sir.
Your slide is not moving.
Now it's sir.
No. Still on the title page.
Okay, sir. Now it's visible, sir.
Yes, it's visible.
Yes.
Okay, sir. Now, sir, as we know that many challenges which are dealing with the smart cities concept, so we have a more cyber attacks that can affect on our smart cities infrastructure. Basically, malware, ransomware attack, DDoS attack, and some insider threats that will target our vital infrastructure parts and internet of things devices, means many IoT devices, and also it compromises with the networks and data repositories. So basically we can say that the ransomware is a global cyber threats that particular log the screen of a users and encrypt their data, personal data as well. So whenever we have to preventing that type of access, so we need to pay something as a ransom. So in some of the example like a local ransomware crypto ransomware, WannaCry ransomware, that are both having some encrypted data and preventing user from accessing their personal device as well as personal device data. So many researchers use advanced technology to deal with this particular type of problem. So here we just see the basic scenario of it. Now here just look at this how we can find a ransomware and goodware type of particular software. So basically, as we can see in this figure, so general scenario is that whenever we are giving some input like a executable file, if we are installing, then our particular processing model that predict that particular file is goodware or not. So it having some hash code and some header files that we have to detect in our predictive model. So based on these particular studies, we can work on these particular problem statement. So what is our problem statement? So actually ransomware is a global cyber threat that using a sophisticated algorithms that to spot and identify unusual as well as the suspicious patterns in our system. So many researchers, they are leveraging on a machine learning based some strategy, and they are finding that particular solution that resolve these particular type of cyber attacks. And basically it deals with a network traffic, system function, and the file activity which can be done under these particular type of cyber attacks. So now what are the objectives of this particular research? So our first research objective is we are introducing one framework that basically used that basically used machine learning algorithms, and based on that algorithms it identifies and characterize that type of data from our particular model and predict the proper output related to that. It is a goodware software or ransomware type of particular file. So in and second objective is we are demonstrating a different models and generalize their performance based on different training set ratio and on a different samples. So these are the objectives of our research. Now let us start with our methodology. Here we are using one ransomware detection dataset. That dataset is available on Kaggle. So first of all, we are processing that data, and some selected features we are using for our particular research problem, and split our data on a different training set ratio like a 70/30 and 80/20, as well as we have used different samples like a 1000, we have a 1000 data, 10,000 data, like different samples. On that particular different samples we have train and test our data in a different ratio, and then we have applied these three classification models. Here first we have used a support vector machine, XGBoost, and random forest, and then based on that we are preparing some evaluation result that concluding something. Here based on this particular methodology we have identified different results, as you can see in the next slide. Now here all of you can see the result of our different algorithm like a support vector machine, XGBoost, on a different data sets. So we have started with 1000 samples, 10,000 samples, 25 and 50,000 samples, and it generates a different result. So as you can see in this particular slide as well as the next slide. So in figure 6, we have comparing this all three machine learning algorithms result accuracy. So SVM generates accuracy around 89.46, XGBoost generates a 92.95, and the random forest that working well and giving us accuracy around 93.58. So here the confusion matrix of random forest algorithm on different samples that are given. And we are also comparing our model random forest systems. It's a very high accuracy and it is better than the previous research. So based on that, we can conclude that our particular framework that working well, and it is poses a significant threat that we can handle it by using this random forest algorithm. It also consists of precision scores across 5 cross validation steps, and it giving us a highest accuracy among that particular algorithms. So basically our future direction or future scope is that we want to work in federated learning to get a more better output related to this type of problem and this type of data set. It can be working well, and we can make a we get a higher result based on that particular practical we perform. So thank you from my side, sir. I have completed my presentation. Hello.
Any question from anyone? Hello.
Yes, ma'am.
Is there any question from any participant or from the session chair?
No, ma'am, no.
No.
Chalo. Thank you, ma'am, for your presentation.
Thank you, ma'am. Thank you, sir.
No.
Anyone want to anyone present who want to present their paper? Okay. So paper ID 855. Anyone from paper ID 855? Anyone from paper ID 1160? Anyone from paper ID 1224?
I think no one else is there to present their paper. So we have come to the end of this session. I really thank the participants for their presentation, and big thanks to our session chair, Dr. Naveen Anand Kumar and Dr. Shubhan Mahajan. Thank you so much for joining us. Being an afternoon, Sunday afternoon, thank you for joining us. And I really enjoyed the way you interacted with the participants. Thank you, sir. So thank you for joining.
Thank you, ma'am.
Now I will
Thank
close
you.
this session.
Thank you. Thank you.
Thank you so much, all present here. Now you can leave.
Okay. Thank you, everyone.
एक सेशन हो गया